Hey everybody, today we're going to dive a little bit into the immune system, autoimmunity, and the role that proteins and peptides might play in our immune system. So, although the immune system is pretty well regulated in most of us, autoimmunity does occur when autoreactive immune cells are mistakenly target the body's own tissues. This can lead to our host system failing to distinguish our self from non-self cells. And it happens due to several underlying factors. It could be a genetic predisposition where certain genetic factors, they can make up some of us more susceptible to an autoimmune disorder. These genetic variations can affect the immune system regulation. They can also increase the likelihood of immune cells mistakenly identifying self tissues as foreign. There can be environmental triggers. So environmental factors such as infections, exposure to certain chemicals, toxins, or drugs, these can all trigger immune responses. Infections, for instance, they can cause a molecular mimicry where the immune system confuses self tissues with foreign pathogens. There's something called immunotolerance breakdown, where the immune system has a mechanism to distinguish between self and non-self cells. It's known as immunotolerance. Basically, a breakdown in this mechanism can lead to a failure to recognize self tissues, which can cause the immune system to literally attack them. Regarding hormonal factors, some hormones can influence immune responses. For example, autoimmune diseases are more common in women, suggesting that a hormonal difference may play a role in the development of these particular conditions. We're not going to touch too much on that right away here. Dysregulation of immune cells, so you've got something called regulatory T cells or Tregs. They help maintain the immune tolerance by suppressing autoreactive immune cells. Dysfunction or deficiency in these can lead to an unchecked immune response, and this can target itself against your own self tissues. Another would be chronic inflammation. So persistent inflammation can contribute to autoimmunity by continuously stimulating the immune system and potentially leading to an inappropriate immune response. Epigenetic changes is another one. So when we see epigenetic modifications which can affect gene expression without altering the DNA sequence, this can also influence the development of an autoimmune disease by altering the regulation of the immune system genes themselves. Autoimmune diseases can impact either a single organ, multiple organs. Organ-specific diseases include celiac disease, type 1 diabetes, MS, myasthenia gravis. Systemic diseases would be considered to be something like rheumatoid arthritis or SLE, lupus. They affect multiple organs. Additionally, an overreactive immune system can lead to allergies or hypersensitivity by reacting to harmless antigens in the environment. In these particular cases, immunomodulation is essential to manage the consequences of a dysregulated immune system. Now, immunomodulating agents can be categorized based on their actions. So some of these suppress or block the immune system completely, which can be beneficial in treating immune diseases, allergies, asthma, inflammation, even during organ transplantation. Others stimulate or activate the immune system, useful in fighting viral infections and cancer. So there are agents that target and remove specific unwanted cellular subtypes within the immune system. This might be applicable in an autoimmune disease or in cancer. These agents can be really small organic molecules, antibodies, or even peptides. Which brings us to peptides. So peptides, which are natural components found in a variety of plants, meat, fish, they're very similar to proteins, but they contain far less amino acids. Now, these amino acids are the building blocks for both peptides and proteins, but the smaller chains in peptides make them way easier for the body to absorb. This property also allows peptides to readily penetrate various tissues and enter the bloodstream for very quick utilization by the body. Like proteins, many peptides help maintain cellular function and regulate the autoimmune response, aiding in the body in healing, regeneration, and protection. There's thousands of peptides and peptide types, each characterized by its unique sequence of amino acids, which determines their specific effects on the body. Peptides believed to have health benefits are known as bioactive peptides, and they're often used in supplements to promote health and well-being. Thymosin alpha 1, which is a peptide naturally produced in the thymus gland, plays a critical role in the development and function of T cells, again, your immunity. And of course, these are essential for combating infections and diseases. Thymosin alpha 1 can enhance the production and activity of the T cells, which really boosts the immune function and reduces risk of infection and disease. So it's a pretty important one. LL37 is a peptide known for its potent antimicrobial and anti-inflammatory properties. It's also produced by immune cells. It's vital in protecting the body against infections. LL37 also helps reduce inflammation, which would improve immune function and lower the risk of chronic disease. Alpha melanocyte stimulating hormone, or alpha MSH, is another peptide, and this one's produced by immune cells, and it plays a key role in regulating immune response. It helps balance cytokine levels, reduces inflammation, and stimulates the production and function of immune cells. Hot topic is the next one, glutathione. This peptide is critical for antioxidant defense, protects the body against oxidative stress. You're going to hear more and more about this. And this can impair immune function and increase the risk of chronic disease. Glutathione boasts antioxidant defenses. It improves immune function and reduces the risk of chronic disease. Thymosin beta 4, or TB500. This is a peptide essential for tissue repair and regeneration. It also stimulates the production and function of immune cells. It enhances immune function and reduces the risk of infection and disease. So, why do these work? What's the big fuss? Well, getting into the science a little bit, structural and functional studies have shown that protein-to-protein interactions are essential for signaling processes between cells. So protein-to-protein complexes are transient and reversible. And in the immune response, these interactions are dynamic. The signal strength and duration depends on the nature of the interaction between the cells. And the amino acids on the surface of the proteins, they provide a high specificity and affinity, or bond, yet allow for a dynamic binding. And since these protein-protein surfaces consist of amino acid epitopes, peptides are well suited to modulate these interactions. And peptides can mimic the surface of one of the interacting proteins. They can disrupt the protein-to-protein interface and adjust the signaling. And this modulation is particularly important in the immune response, as it allows for fine-tuning rather than completely shutting down the signaling process. So, in a nutshell, peptides can bind to surface proteins on cells and affect the body's immune system of regulating itself and recognizing those cells as foreign or non-foreign. So, there are some other things that we're going to talk about in the next discussion, and that's going to be oral supplementation and what can we take to help boost our immune system. So for now, think this over, send me any questions that you may have, and we'll dive into the individual peptides as we move forward. Thank you.